All right, let's get started. Hey everyone, welcome to Stackschool session 3. Today we're going to be talking about SQL. My name is Nathan. Sneha is over here. We're going to be your co-presenters for this workshop. If you're following along with us for the ACM membership, the password is CQuill, kind of spelled out CQuill. Super fun. Okay. We have linked to slides as well as linked to demo. Do you mind dropping link to slides in Discord for me? Thank you. Cool. All right. Before we get started, I want to announce that Hack on the Hill 11 is going to be Saturday, March 2nd, 2024. So this is a beginner-friendly hackathon. So feel free to sign up. There'll be prizes, food, a lot of great mentorship. You'll see all of us there. So if you have never hacked before at a hackathon, I highly encourage you to sign up. Deadline is February 26th, which is going to be week 8, Monday. It's also on our website, hack.uclacm.com. Cool. All right. Don't forget, we have prizes at the end. So whoever builds a full stack app at the end will have a little showcase and we'll give out some prizes there. Okay. As a recap, our curriculum this week is SQL. Next week we'll cover servers, and then 6, 7, 8, and 9 are listed there as well. And the goal of this workshop is to really set you up for using SQL in your backend when you create your own server next week. Cool. So this is the agenda for today. We're going to start off with some installations and then go into some motivation and then describe what a database is. And then we're going to cover and get into the depths of what SQL is, kind of defining some common queries and schemas that we can use, as well as finding out where SQL is in our app. So first, some installations. On the left here, we have Postgres, and on the right, we have pgadmin. So Postgres is the actual technology that we're using. It comes with a nice shell environment, which I encourage you all to use. And on the right is pgadmin, which is basically a tool that helps us visualize all of our data. And actually, a quick note is pgadmin comes with your Postgres download. You just have to remember to check the little box that says also download pgadmin for. Yeah. If you just Google Postgres, it'll lead you to the downloads page too. All right, and then after you download Postgres, it'll come with the shell that I mentioned earlier. It is located in your applications under the folder Postgres 16, and then it's the SQL shell. Okay, so double click that, and then you'll be able to run SQL commands from there. And that's actually what we're going to be doing in part of our demo today. So if you want to go ahead and download Postgres, you can go ahead and get that started. Cool. Now, let's get into some motivation about why we need databases and why they're actually important. So let's go back to our app here. In our app, we have 3 screenshots from our app. And can someone just tell me where we see data? Like where is data being stored and where are we using data? Because it's everywhere. Think about who's going to be using our app. Think about where we're generating, where we're adding. Some hints could be we have a user, right? We also have songs, right? So I guess the main point of data is we have a lot of users and each user has songs. And from there, we want to basically say, okay, well, we have these users, we have these songs. How are we going to relate them? How are we going to actually create a full stack app out of it? Cool. Okay. Now let's get into defining what a database actually is. All right. So a database is just a structured set of data. Essentially, it stores information in a way that is easy to manage, access, and also update. If you want a really simple example, think of a file cabinet, but much bigger and also more organized. This is just the textbook definition of what a database is. Any questions on what a database actually is? Cool. We'll get into some analogies. So we're going back to our lovely restaurant analogy here. So let's say, for example, a customer requests an order of eggs from the kitchen. And so the eggs are actually representing our data, and the fridge that stores the eggs represents our database. So eggs is data, and database is our fridge. We're going to be talking about the fridge portion today. All right, I get it. But if you're like, okay, I really don't care about eggs, right? How does this actually apply to me? we can think of some real world use cases. So for example, one of the big tech companies I'm sure you know is Google. And if you think about it, data is actually everywhere, right? From their search engine to YouTube to ads, they're everywhere, right? Data is being used every single day to kind of target ads towards you, but target your recommendations on YouTube, but also give you results from your searches. Another one, Meta. So for example, Facebook, Instagram, the like, also Amazon, right? The main thing is shopping. How are you going to get an item if there's no database to store that item? Also, Amazon Web Services also uses a fancy database. Some more examples. You've got Airbnb, Uber, Lyft, Cisco Meraki, Twitch, Apple, Netflix, and Riot Games, right? As a small subset. You have so many of these companies that are just using data all over the place to kind of get you what you want to see. And today we're going to talk about how to get into databases and where we actually organize and are able to create a product using data. And with that, I'll turn it over to Sneha, who will explain relational versus non-relational databases.
Okay, so now that we know what a database is, we're going to be talking about different types of databases, specifically relational vs non-relational databases, and some of the differences between them. So relational databases organize data into structured tables with rows and columns, with each row representing a record or entity, and each column representing a specific attribute. So in this table, item ID, name, quantity all represent different columns, and then the rows are like lettuce, tomato, and broccoli. So relational databases are really helpful because they can be used to relate multiple different tables together through something called keys. And basically, there are two types of keys. There's a primary key, which is a unique identifier for each row within a table, and a foreign key, which establishes a link between a table and another table's primary key. And right now, it might seem a little confusing, but on the next slide, we'll go over an example where I think a visual will make it a little bit clearer. And basically, this structure makes it really easy for us to retrieve related information for multiple tables efficiently and use complex data query to get very specific data, which is stored in our database. So here we have two tables. The first one is ID, name, and courses, and it's related to another table, which also has the same identifier as ID and marks. So can anyone tell me between these two tables, which one they think the primary key is and which one they think the foreign key is? So, okay. So basically in our example, the primary key is the ID in the ID name and courses table, and it's connecting to the ID in the other table with the ID and the marks. Okay. So what's a non-relational database now? Non-relational databases organize data in a more flexible format, and they can be stored in multiple different ways, such as key value, column-based, graph-based, and document-based. In this example, we have kind of like a visual of a document-based kind of non-relational databases, where instead of tables like we were talking about in relational databases, the data is stored in kind of a sticky note format, with each sticky note being a document and the series of sticky notes together being a collection. And each colored sticky note represents a single document. Okay, now going over kind of what we talked about between the differences. So in relational databases, they use structured tables with rows and columns, kind of like an Excel spreadsheet. And they require a fixed plan for how the data looks beforehand. So you kind of have to know what kind of columns you want, the number of tables you want, and how they want to be related to each other. And that makes it really good for organized data. Non-relational databases are used to store data in more flexible ways, such as folders or sticky notes, and it allows you to add or change data without a lot of strict rules. So while this makes data storage and retrieval pretty fast, it's less organized than relational databases. Okay. So now that we know what the differences between a relational database and a non-relational database is, what are we, can anyone tell me what they think we're going to be using for our app? Sounds right. keep in consideration. So in our app, we're going to be dealing with lots of different data like users and connecting it to their information, like their songs, more information about like their password or email, all, and we want it to be structured in a very consistent format. So in order to be doing this, we're gonna be using a relational database. Okay. So why a relational database? In Sounds Right, we want to store our data such as songs, artists, user information in a structured and consistent format. And we want to be able to efficiently retrieve data on specific songs and user details. And basically, the formatting or structure of relational databases between primary and foreign keys makes it really nice for us to be able to relate it to our app where we're connecting users and their favorite songs in multiple different tables. Yeah. And also, relational databases are more commonly used in industry. As Nathan mentioned, a few examples like Airbnb, LinkedIn, and Facebook all use it. And there just is more to learn about them as well. Okay, so now that we know how our data is stored, how are we going to be accessing it? So in order to do this, we're going to use something called a relational database management system, also known as, in this case, PostgreSQL. So what is SQL? SQL stands for Structured Query Language, and it's a language that communicates with our databases to pull information. And SQL allows us to perform a bunch of different functions on our database, such as inserting, updating, deleting, and retrieving data. And basically, it's in SQL, there's something called schemas, which is how we organize our data within our database. And without schemas, it's easy to get lost in data, as many databases can contain lots of different tables and files. So suppose you're giving a file with a bunch of different tables and you don't have a structured format for relating them to each other. In order to find some information from any one of these tables, it would be really hard to navigate through this. So instead, we want to use a SQL schema, which is basically just going to be used to organize our data and group related tables and objects together so we can easily access it and find specific data. Okay, so now that we know how our data is going to be organized, we can use something called a query in SQL as basically a set of instructions that tell the database what we want to do with the data. So suppose we have a warehouse or a container stored with all of our data. And in this little analogy, all of our data is stored here, and our query is basically like a delivery truck going from the warehouse back to us and giving it commands such as show me all the products in our store, in our case, like show me maybe some specific data from our database, or update the price of a specific product, or in our case, maybe update the values of some data in our database. So SQL queries are really powerful because they can retrieve very specific data from databases, and they can filter, sort, aggregate data based on also very specific criterias and perform other functions such as joining tables, grouping data, and other calculations. So here we have an example of a SQL query or a command that we would give when trying to access some data from our database. So we can kind of break it down. So the select keyword here specifies the columns that we want to retrieve our data from. The from keyword specifies the table we want to retrieve our data from, and where filters our rows on specific conditions. So basically this query is accessing a table called customers, then going to specific columns, name and age, and then returning to us rows in those columns where the age is greater than 30. So basically queries allow us to go into very specific tables or parts of our database and get exactly the kind of data that we're looking for based on a number of different conditions that we want to specify. Okay, so in order to do this, we kind of saw before with the select keyword, but SQL has many different commands. the create command is used to create a new table. Insert is used to add new rows to a table. Select is used to retrieve data from one or more tables and print it out. Update is used to modify existing records in a table, and delete is used to remove records from a table. So first, the create keyword. This is kind of the syntax of it. So create. So when you use the create keyword, you want to define the columns you have in your table. So in this case, we're creating a table with a name to-do list, and we're specifying 3 columns with name, age, and item, and then specifying the data type that we want to be held in each one of our columns. So for each one of our columns, in the previous example, um, we have like a character type, integer type, and another character type. So basically there are different types of data types where if you've taken like CS31 or any programming class, some of these probably look familiar. So the bar chart, I think that's how you say it, data type basically stores character strings of max length n. Integer stores integers, date stores the date, times stores the time, and timestamp stores both the date and the time. And one that's not as self-explanatory probably is serial primary key. So before we mentioned that relational databases use primary and foreign keys to relate tables to each other. So if you have a table and you want to create a column with a primary key to relate it to another, you would specify it as a serial primary key. The keyword serial is really important because it automatically generates a unique integer, so that each key in our row has a unique value and maps exactly specifically to another unique value in another table. Okay, and some more keywords. There is unique. So unique basically specifies that in each row in a column should have unique values, and not null, which means that a column cannot contain null values. So in this case, if we're specifying that we want our column containing emails to have the data type of character, then unique basically means that each row in the email column should have a unique email address, and it should not be empty, should not be null. And the same for username. Okay, going back to some more of our SQL commands. So we went over the create command, and in our app, we're also going to be using the insert command to insert in new rows to our existing tables as we get more data and we want to add it to our database. So the syntax for that is just insert into to-do list, which is our table name, and then specify the values for each column that we want to insert in. Okay. And then the select keyword can be used to display information from our tables. So if we want to retrieve data and be able to like access specific elements, we can use select. So select asterisks from to-do list will print everything in all the contents in your table, and select name, comma, age from to-do list will print out specific columns from your table. And just a side note, so select asterisk is sometimes considered a bad practice because it may cause issues when editing and querying in the future. So it's better to be specific about the types of data that you want to print out and specify exactly what columns or what conditions you want to get when you're querying for data. Yeah. Okay, so now for a quick demo. If you have pgadmin and psql downloaded, you should be able to open the psql shell, and which is a different shell than the terminal where we're going to be running our SQL commands in. Or if not, also, if you have them downloaded, you can open your terminal and type in psql u and the username you created when you downloaded psql. Okay. Okay. Okay, so your terminal or your PSQL shell should kind of look like this, and basically this Postgres equals hashtag just means that you're now working inside of the Postgres shell, where you want to be running your SQL commands. Okay, should I start? Should I like wait for people? Okay, okay, so I'm just going to be demoing creating a simple database and creating two tables within it related with the concept we talked before about primary and foreign key. Okay, so first we're going to create a database using the create database command and name it something like my database. Okay, so if you got this, that basically means that your database has been created. And then now we just want to enter into the database that we created. So we can use C my database base or whatever you just named your database to be. Okay, and then it says you're now connected to database and we're working inside of the newly created database that we created. Okay, so now we're gonna first create a table, and I'm gonna create a table called students, containing of just some basic information like their ID, date of birth, and email. So first I'm gonna do student ID, and I'm going to specify this as a serial primary key type. So then this is basically, this column is going to represent my primary key, which I'm later going to connect to another table through a foreign key. And then I'm going to specify name of type, character, and not null, which means that I don't want it to be empty when creating it. And I'll add in like date of birth, and some more columns like email. And for something like email, you want each user to have a unique email. So I'm going to use the unique keyword and again specify not null. And then to finish creating it, I'm going to, oh. Oh, okay. I think you have to use a parentheses, not a bracket when creating a table. So I'm just gonna copy paste all the commands I wrote before using a parentheses. Okay, so my table has now been created, and I'm gonna create another table, which I'm gonna relate to this table and call it courses. So create table courses parentheses. And have course name, teacher, and I'm gonna now connect my student ID to the student ID I defined in students by referencing it as student ID int references the student ID that I defined in the students table. And then, oh, okay. I'll make it again using the correct. Um, okay, so our next table has been created as well. And now we're just gonna go over the basic syntax for inserting data into our table. So I'm going to use insert into and first insert data into the students table. So I'm gonna specify the name, date of birth, and email. Oh, and add. Okay. Okay, and then add in my values. I'm gonna name my student Nathan, specify my date of birth, and include okay, and add an email. Okay, and that inserted one row with the value Nathan and date of birth and email. And now I'll insert in a corresponding value to our courses table, including the information that we defined there. So insert into courses, course name, teacher, student, ID, values, for course, oops, CS32. And so in my students table, I didn't define clearly a serial primary key. So it basically just goes in order and it auto assigned it to 1. So when I'm referencing it here, I'm just going to use 1 to reference the first row in the students table as well. Okay. Okay, yay. So now we have our data in our database, and just if we want to maybe print it out, we can use the select keyword. So select, and if I want to print out like the email, I can do select email and then specify from students and then specify where when name equals to Nathan. And basically our query resulted with it printing out the email that we entered in earlier as natec@gmail.com. Yeah, okay, so that was the end of my demo. And hopefully through this, you're able to see just how these basic SQL commands can be used to modify data and insert data and get data back from your database. Okay.
Nice. Thanks, Sneha. So now, the last portion of this is basically seeing where SQL is in our app, right? So we covered the basic introduction of some basic SQL queries, but now we're actually going to apply it to our app. So again, back to our app. Like I mentioned before, we have some users and we have some songs, right? Naturally, the thing is we want to use a users table, right, to store all of our users, and a songs table that stores all of our songs, right? So we're going to go ahead and do that. Users table and songs table. But now if you remember, we have a functionality of liking, right? So how are we going to use that, or how are we going to implement that functionality? Can anyone take a wild guess as to what we're going to do? Any ideas of what we can do to implement the song likes functionality? Correct. Create a new table. That's exactly what we're going to do. So we're going to take advantage of relational databases, and we're going to create a new table that relates a user to a song. Essentially, we're able to look for whether or not the user has liked the song, and so on and so forth. Excellent. So users table. What kind of information needs to be stored in said users table? So I've listed them out here. This is what we've gone through. So we have an ID, and once again, that is going to be your serial primary key. That's going to be automatically generated whenever you create a new user. And then we're going to have a user is going to have an email, a username, a first name, last name, a password, and then a profile picture. In this case, the profile picture will simply be a link to the actual profile picture, not the actual picture itself, just to make it easier on us. And so this is great. We've essentially defined what we want in our users table, right? But how do we actually create the schema that comes with our users table? And that's going to be the next slide here. So users table schema. We have an ID, like I mentioned, that is going to be a serial primary key, right? An email is it going to be an integer or a string or null value, or can anyone guess? It should be a email should be a, like, anyone? Yeah, it should be a string. And in SQL, we use varchar 255. So it means that it's the maximum length of 255 characters. Same with username. First and last name is also going to be a string. Password is also going to be a string. And then profile picture is also actually going to be a string. So yeah, this is what that schema is going to take a look like. So we have an ID serial primary key again. We're going to have an email. We want to make those emails unique, so we use a unique keyword. We have not null as well, because we don't want someone to sign up with an empty email, because that makes no sense. We also have a username that's not null, a first name that's not null, last name that's not null, password that's also not null, and then the image, we can have it be null for now. I feel like that's fine. We can just input on the front end, we can just insert a template, temporary image if necessary. Cool, so that's our users table. Next, songs table. So what kind of information needs to be stored in the songs? Well, again, we're going to have a song ID, and then that is going to be our serial primary key for each of one of our songs. And then we have the user who added the song, the artist of the song, the title of the song, and the date it was added, and then also the number of likes per song. So more formally, what does that look like as a schema? That means we're going to have ID serial primary key. Again, serial means it's going from start from the beginning and then go to the end of however many songs you have, and they're automatically generated. We're going to have a user ID. Now, this is important because this is actually going to reference the user who created and added the song. So again, it's an integer that references the user's ID. References, again, is SQL's way of saying this is my foreign key that I'm going to use. And ID there just simply means that it's relating to the ID that's in the users table. And then artist, title, date, likes, pretty self-explanatory. Except the likes, we're going to set the default to 0. You can set it to any value that you want, but we're just going to say 0 because it makes the most sense here. And lastly, the song likes table. It needs to store an ID and the song ID of the actual song itself, as well as the user ID of the user who actually liked this song. So this one's pretty easy in the sense that all it needs is 3 values in the schema, and it just needs to have the ID serial primary key, as well as the integer references, the song ID, as well as the references user's ID. So this is going to be able to relate a song to a user. Questions? Excellent. Great. So now let's go ahead and get into a demo and actually open up VS Code for the first time this workshop. Okay, so let's go ahead and create our backend. So last week, we talked up to the point of having a functional front end complete with navigation, use state, use effect, components, like we mentioned in the previous few workshops. So now we're going to take all the code we created and we're going to group it together into a folder called front end, or a directory called front end. Typically, this is best practice to organize your full stack app. If you have a directory called front end and a directory called back end, you can start the 2 servers separately, essentially. So if you don't have this already, you're going to create a new folder called frontend and put all your code from last week into this folder. If you already have it, skip this step. And then you're going to create a new folder called backend. And in backend, the only thing we're going to do to backend this week is create a new file called databases.sql. I'm going to go ahead and demo that here. So here, this is my app from last week. Notice how everything is here, and I don't have the folder front end. So what I'm going to do is I'm going to create a new folder. I'm going to call it front end. And then I'm going to go ahead and select this, and this. And I'm going to drag and drop into there. Boom, done, front end. Clean up. Cool. And then here I'm going to create a new folder called backend. And you'll notice how backend and frontend are in the same directory. So make sure you do not create backend within frontend. That's going to cause some errors. And the reason why we have a backend folder is because we're going to have more than one file in there, obviously. When you get the servers next week, you'll know why. And then within backend, we're going to create a new file called database.sql. Voila. Cool. Okay. So this file is where our schemas will actually live. So those schemas that I defined in the 3 slides previously, that is where our schemas will live. And again, this is good practice because let's say that you have never defined these schemas and your app, you have no idea what your database looks like. If you have multiple people working on this app, everyone's going to get lost. This is also really good for reference, first of all, like I mentioned, documentation, so you know exactly how your schema looks. For data initialization, sometimes this file will also include some default numbers. So let's say just by default, when you create this database, you want to actually create X amount of users, just for your test subjects, for example. But also for data migration. There's just a more advanced topic, but just know that having this template there will help you a lot in that step. Cool. So in database.sql, we're just going to be adding this code. So we're going to have create database, which is SR database, and then we're going to create 3 tables, which is users, songs, and song likes. Cool. All right. So I don't know if you want to actually see me type all that in there, but just know that it's in our demo. So it is going to be there. It's also on the slides here. This is what your final one should look like. I've gone over all the schemas, and essentially what this does is just documentation for us. Note that we haven't actually created our tables by typing it here. We need to actually go into Postgres and go through the entire create database using in the Postgres shell, that is, create database and create table, such as Sneha mentioned. Cool. Okay. So this takes you through the steps. In the Postgres shell, they have some special commands, which is \l, which lists all the databases in Postgres. \c, which helps you move inside a database, and then \dt, which helps you display a table within a database. This is all really cool and great and nifty, but I'm going to show you a tool that basically doesn't have you use this at all, and that is pgadmin. Cool. So off to my section of the demo. Where is it? Here it is. So I've already pre-created a database with the same schemas that we've looked at. This is pgadmin. All you need to do is go ahead and click servers, Postgres. The pop-up will there will be a pop-up asking you to input your password that you've created when you downloaded this, and then you go into my database, which thankfully Sneha did not use an underscore when she created her database. Otherwise, she would have resulted in an error because I have one here named my underscore database that I'll be demoing out of. And you go into your schemas and you take a look at your tables down here. So if you notice, we have song likes, songs, and users. So those are going to be my 3 tables that I'm going to demo here. pgadmin is great because it's a user interface and you don't need to actually go through the terminal to create everything. So let's say I wanted to create another table. I can just right click here, create table, and input everything that I need to do without having to actually specify the specific schema. This is great. But for now, I'm going to stick with these 3 tables. And let's actually take a look at what's in my tables here. So if I want to do that, I right click and I say view and edit data. And I'm just going to say the first 100 rows. I only have 3 rows, so it doesn't really matter. Voila. So if you take notice, I have created 3 users here beforehand. They are Jenna, James, and myself, apparently. And with values email, username, first, last, and then password. As well as the image, I just left it as null because no one really cares. Cool. And notice how the ID is the serial primary key. It goes 1, 2, 3. If I were to delete, let's say number 1, if I were to delete number 1 and create another one, what do you think the ID would be? Any guesses? James, do you know?
If you created a new one,
Yeah, so I deleted the
it would
first
keep
one.
going sequentially, right?
Correct. Yeah, it would keep going sequentially because that makes the most intuitive sense. You don't want to have like a new user take place of like user ID number 1, because what if you're still referencing user ID number 1 somewhere and you're like, oh, this is no longer the same user I'm looking for. Okay, so it makes sense to keep increasing sequentially, and that is the power of serial. Cool. So here I have 3 users. Let's take a look at all my songs. Yeah, question. How do I clear the data? Good question. So let's say a user deletes their account. So first of all, you would need to probably look at where that user has had like inputted data. So in this case, we have songs that are linked to the data to the user, right? So you probably have to query for, first of all, you're going to query for the actual user itself, and then you're going to take a look at, oh, okay, I'm going to delete all the songs that the user has added, right? Using that relational database that we've talked about. And then you're going to finally delete this actual user. So it's kind of you need to keep track of like where the user has kind of touched data, and then create those queries as necessary. Yeah.
So
Does that kind of answer your question?
if let's say like the number 1 spot
Yeah.
gets freed up,
Yeah.
will we ever allocate a new user to that, or will it just increment sequentially?
It would increment sequentially. Typically, it also depends on like I believe it depends on implementation, but most of the time it will just increment sequentially. Because like I mentioned, let's say you're running into a problem where you've deleted number 1, right? Like Jenna's gone, right? But you've put someone in like Max, right? But Max may not be a K-pop lover, but you're like profiling him because of whatever you have previously, right? So it doesn't make sense for you to have like 2 different things relate to the same ID. Cool. Yeah. Did you have a question?
Yeah.
Cool. Nice. Okay. So that's my users table. And then next I'm going to talk about or take a look at my songs table. Let's just take a look at the first 100 rows. I have 16 songs here. I created them in order of user ID, which in retrospect, I guess I could have made it more interesting and add like different ones. But if you notice, everything related to number 1 is K-pop. Everything related to user number 2 is American pop, and everything related to number 3 is like mostly Millennium, except for one, BTS, which I like. So that is my songs and my users. So if we want to insert something, pretty simple. We can just say insert blah blah blah. Insert, like run these commands that Sneha had previously like said. So insert into like this would be songs. You have to name your columns, and then your values have to match the number of columns. So let's say I have 4 columns that I want to insert to. I have to input 4 actual values. And the thing is, if you're looking at the slides and you try and copy paste values, like copy paste commands into the slides, it won't work because Google Docs is stupid, and the way they encode an apostrophe is different from the apostrophe that SQL expects. So just make note of that if you're copying from slides. Yeah, you would need to manually change all the apostrophes to like the straight one and not the curvy one. Okay, so this is all done. I pre-did it for you, but let's go ahead and see all the songs that we did, which we just did. Now let's look for songs that user 1 added. So someone help me create a query that looks for all the songs that user 1 has added. And user 1 in this case, I'm just going to say has ID 1. Can anyone help me? I actually don't know the answer to this. I don't think I created an answer to this. So we're going with it. And in order to actually run a query, we're going to do this. Click this top left button here, and we're going to run it. Cool. So let's say we're looking for users. So I'm going to say select Let's see, I'm going to get their username. I just want that column, select username from the table users. And I realized that I actually need to do a join in this case because I have to relate all of them. So actually, no, I don't. I actually do not. Or I do. So in this case, since I want to relate between two tables, like the question I'm asking is, I want to be able to find like all the songs that a specific user has added, right? I can't get that solely from a users table. I also can't get that information solely from a songs table. So I need to do something called a join, which actually I'll go into detail on the next slide. An example on the next slide. So the challenge that I had here, I didn't expect this last bullet point to be a challenge because I just created it at night. I was like, but it's okay. We're gonna go with a little challenge here. So this little challenge is find all users by username who have added at least one song by BTS. And so what we're gonna do here is, again, you cannot just simply reference a users table and a songs table. You have to relate the two. So this uses something called joins in SQL, which is a command that is very, very powerful. And that's why a lot of people actually use relational databases. Yeah. So what the join essentially does is it takes your primary key and your foreign key, mushes those two tables together in a certain configuration based off of what you've kind of said. And then you're able to look for values there. Okay. So to start off, we're going to select distinct users.username. Distinct just simply means that when I'm going to return things, I don't want to return like multiple of the same thing. Okay, so distinct just means get unique, for example. I want to get the user's username, okay, since I've specified by username. Now I need to select from what? I'm going to select from my users, okay? So I'm selecting distinct usernames from my users, all right? But how am I supposed to get all the BTS songs, right? I need to somehow mush together users and songs, okay? And I'm going to do that with the primary and foreign key relationship, which helps me with join. What this does is it says join songs on users ID equals songs ID. And what this essentially does is it takes your users ID table, it takes a look at that user ID column, and then it takes a look at your songs table. And because in your songs table, we have a foreign key called user ID, and all it's going to do is going to mush it together. Now you have a big table, okay, that helps you get the relationship between a song and a user. And now it's very easy for us to say, okay, now I want to get all the songs that have BTS as the artist, and I'm just going to return them. That's all I'm going to do, okay? And intuitively, it makes it, you can think of it as like, oh, what if a user has like multiple songs like by BTS, right? It would return every single entry in that row that has BTS, right? But to combat this, we have the word distinct. Okay. So what that kind of looks like is where songs.artists equals BTS. And that's going to be the end of my query. So again, I'm looking for the songs artist equals to BTS. That is what I've kind of given you as the problem statement. Cool. Anyone have any questions? I know I kind of just like plotted joins on you guys, but yeah. Questions? No? Okay. Let's actually try this then. So if I run this query, if I copy it and I move it over to here, again, I'm going to change my quotes because this is stupid. If we go back to my songs, notice how if we just take a look at these songs here, there's 1, 2, 3 songs that are BTS, right? These two BTS songs up here are inputted by user 1, and this last one is inputted by user 3. So when I'm querying this, it should return the username of user 1 followed by the username of user 3. And it should not return the username of user 2 because user 2 does not have any BTS songs that he likes. Cool. So what this looks like, hopefully I did it correctly. If not, oh well, I'll fix it. But if I execute this script, there we go. We have EDM and then K-pop forever. Cool. So EDM was the username of, if you take a look at the users, user3, username EDM, and then K-pop forever as well. And that's what this returns. All right. So you can kind of see how we can build queries that are super powerful, right? We can have, two separate tables that maybe don't relate to each other, but we can add a foreign key, and then we're able to create queries that are really powerful that kind of give us cross-table, querying power. And this kind of relates to our actual app, because if you can think about our actual app, right, we have someone is going to like a post, someone's going to create a song. Can you actually think of any other ways where we need to query data from our database to kind of get the full functionality of our app? And that is something I'll leave you guys for next week, because next week we're going to take these SQL queries and add them to our server. And they will explain next week how to do so, but essentially this is the backbone of how our backend is going to work. Any questions on that last point there? Nice. Awesome. Well, with that, then I think that wraps up our session. So we introduced databases with relational versus non-relational databases. We learned a bit of SQL, including their schemas, as well as query building, such as using the select, insert, update, etc. We set up our own Postgres database locally, and we ran a few queries to test our knowledge. And with that, thanks for coming, and hopefully we'll see you guys here next week when we build our own servers and actually use our SQL commands to query our data. All right, see you all next week.